Hey everyone, today we're going to keep going with surds. So last lesson we were adding and subtracting like surds, and today we're looking at multiplying and dividing surds. In order to do this, we're going to have to use some of those surd rules that we learnt about last term. As a warm-up, I want you to have a go at these three questions here. I want you to write down all your working, take a photo of it and upload it to the warm-up section in our OneNote, just so I can see how you're going. Pause this video, do that, and then we're going to get stuck into multiplying and dividing surds. So as you can see, multiplying and dividing surds, we have a range of examples that we're going to go through today because there are so many different ways we can work with this. So the simplest one, or the first one, we have here in example A. It's where we just have integer times a surd times an integer times a surd. Okay, so it's as simple as multiplying everything together. So we can multiply our integers. 2 times 3 is 6, and root 3 times root 15 is root 45. So we have to apply that surd rule there. Now, we need to make sure that in every case where we're simplifying those surds as much as possible. So root 45 can be simplified further. It's 6 root 9 root 5 because 9 5s are 45. That root 9 is going to turn into a 3. So we've got 6 times 3 root 5, which simplifies to 18 root 5 as my answer. So when it comes to multiplying and dividing surds, really we're just putting all of our surd knowledge together. It is arguably easier than what we did last lesson with adding and subtracting surds. Now, with part B, we can use our index laws that we learnt in year 9 for this one. So if we see a squared outside the bracket, what that means is we're going to have to square the 2 and square the root 5. Now you may recall, and we spoke about this a bit last term, if we see root 5 squared, that just means that the answer is 5. So that's always true. It's just the answer under the surd sign. So if I go 2 squared root 5 squared, so that's me applying that squared to the 2 and the root 5, I end up with 4 times 5, which is the nice number 20. So we might see examples like that. Let's move into something else. Let's move into our division now. So what we're going to do here is we're going to combine this as one surd. All right, in the same way, we're going to combine this as one fraction, or just evaluate that green side. So 12 divided by 3 we know is 4, and then we can write that yellow highlighted section as root 18 on 3. Now 18 on 3 is just 6, so we can just write the answer as 4 root 6. And that's it. And we know that root 6 cannot simplify into anything further. It has no perfect square factors. Let's move over now into some harder examples. We notice here now we're going to have to expand. All right, so this is just bringing in our knowledge of expansion from our algebra unit last term, where we have surds involved as well. So we're going to make sure that we're showing all of our working out for that. So the first thing we're going to do for question D here is we're going to go root 3 times 3 root 5. So 3 root 5 root 3. I'm just going to put the root 3 at the end there, so it's easy for me to combine those surds later. We then have root 3 times negative root 6. So that's minus root 3 root 6. All right, let's pop that all together and see what we get. We get 3 root 15 take root 18. Now, we need to be careful. We're not done. This root 18, well, we know 18 has a factor of 9, which is a square number, so we need to be able to simplify that. Root 15, however, cannot be simplified, so we can keep this whole term how it is while we work with this term here on the right. So 3 root 15 minus root 9 root 2. Okay, and then we're going to get a nice integer of 3 falling out there. So 3 root 15 minus 3 root 2 is our answer for question D. And no, it doesn't look that much neater because there's only 2 terms, but that's okay. It doesn't always have to be a nice simple surd or a simple integer like in questions A, B, and C. Let's move to question E. And again, if you want to have a go at these, pause now and have a go at them yourself, okay? We might have cases where we have 2 brackets and we're going to have to use our FOIL method, first, outer, inner, last. So let's get started with that one. Let's start with first. So we've got root 2 plus 2 root 2. So it's just a bit of a habit there that I'm doing, that I'm always putting the surd at the end, just because that's how I'm going to end up simplifying it at the end anyway. Plus 7 root 2 plus 7 times 2. So let's put this together. I'm going to end up with root 4 plus, and I've got some like terms here. I can see them. I've got a root 2 and a root 2. So this is where we're going to use our knowledge from last lesson. Plus 9 root 2 plus 14. I notice here that I've got a root 4, so we're going to have to evaluate that. 2 plus 9 root 2 plus 14. And we can add that 2 and that 14 together to get 16 plus 9 root 2 as my answer. Okay, so let's take a moment now. I just want us to write in something else. So just like over here we wrote in blue, that was just sort of a little key thing to understand. I want to talk to you now about something that you might have learned in year 9, might not have. It just depends on where you were and how your class was keeping up. If we have a case where we have A plus B multiplied by A minus B. So what I mean by that is if we have the same first term here and here in the bracket and the same second term, but the difference between the brackets is that one has a plus and one has a minus. That means our answer is always going to be equal to A squared minus B squared. Always. That's always true. And we call that the difference of perfect squares rule. And it's going to help us a lot in example F. By the same token, we also have a situation where we might have A plus B all squared. Now in this case, we're always going to end up with A squared plus 2AB plus B squared. Okay? And that's just your perfect squares. And that's going to help us a lot with example G. Now you don't have to know these off by heart. You are very welcome to manually work out F and G in the same way we worked out E with the FOIL method. That's completely fine. It's just this way gives you that little bit of a shortcut if you're running short of time in an exam. If you don't trust me, please take the time now and expand this and note that you will end up with these answers. So let's get started on F. So with F, we have a difference of 2 squareds. We can see we have 2 as the first term in both of these brackets and root 5 as the second term, and the difference is 1 is a plus and 1 is a minus. That means my answer is just going to be 2 squared minus root 5 squared. And just like we reviewed over here, when we see a root 5 all squared or a square root of something all squared, it's just the number under the surd. So that's 4 minus 5, which gives us -1. And how cool is that? We had this really big ugly thing and it made it a nice -1 as our answer. So that's an example of a difference of perfect squares. Down here in G, if you want to have a go, pause it now. We're going to use this example. All right, so this is just a perfect squares expansion. If you want to write that out in full, that would be 7 plus root 2, 7 plus root 2. And you can just expand that with the FOIL method from there if you prefer. Okay, but what I'm going to do is I'm going to jump straight to the answer I know it's going to be. I've got root 7 squared plus 2 root 7 root 2 plus root 2 squared. And I'm immediately going to simplify that root 7 squared to 7 plus 2 root 14 plus 4. My 7 and my 4 are like terms there. So that's going to give me 11 plus 2 root 14. And root 14 has no square factors, so this is my answer. Now I know that was a lot of examples, but that's just because there are so many different ways that we can multiply and divide surds based on all the knowledge that you currently have. Now, before I get you to get stuck into some questions, I want you to have a go at these 5 here. And I will let you know as well that with these 5 here, this is an example of each type of the ones above. If you're checking your answers, please note the answer for A will be root 15. The answer for B will be 42 root 6. C will be 13. 4 will be 30 root 2 plus 15 root 30. And the final answer there will be 4. Okay, but make sure that you actually get to those answers with your working. Okay, once you've done that, have a go at exercise 3C. If you question 4 to 8, just do ACE, and we've got our special ones here, question 9 and question 16 for a bit of extension. Furthermore, though, we have an additional worksheet to work on these difference of two squares, difference of perfect squares and perfect squares, and this is the binomial worksheet. I'll pop that up on eLearn for you. It's already on the Common eLearn, but I'll pop it on ours. Just working on questions 4 to 9 ADG, and if you want a bit of extension, you've got question 14 AC there. I've also just realized that that one's not quite right. Okay, that one there should be root 50. All right, thanks guys, and if you have any questions, make sure you email me.